So on behalf of the Love for Lucas Foundation and the foundational partners of the DIPG and DMG Collaborative, we would like to present to you with a grant award for the ICANN School of Medicine at Mount Sinai of $100,000 for the study preclinical evaluation of TP-0184 in autogenous mouse model of DIPG and DMG.
Oh, thank you so much. That's so kind. I'm very grateful. You guys are amazing. We've been at this for a long time.
Yeah, exactly. Your grant to test the targeted therapies, it looks really promising. We're really supportive of your dedication in the study of DIPG and DMG. We look forward to hearing great things about the progress towards our ability to prioritize the therapies for patients with DIPG and DMG. And just a note, Dr. Becher and I had the pleasure of meeting several times over the years, and we last, as I mentioned, we last met in November at another DIPG fundraiser event, and I can say that your dedication for cancer research and for DIPG specifically is really inspiring. And I'm lucky to be in New York with you and look forward to visiting your lab in 2024. And again, congratulations on the grant. So I'll turn it over to Keith, our chairman and co-founder of the Cure Starts Now and the DIPG Collaborative. Congrats again.
Yeah, thank you so much. Yeah, I actually didn't realize when I saw you at that fundraiser that you're part of the DIPG Collaborative. I guess I had
am
no
as well.
idea. Yeah. So you're everywhere. Well, like I said, we couldn't do this without the partnership. I sit on NIH study section, and I cannot tell you how many grants of mine that I submit to NIH do not get funded. Of course, occasionally I do get lucky, but it's just but I think, like I said, I believe in the mission. I believe that our tools are providing a unique angle that will help in the long run. And so I just keep going. So thank you. And obviously
That's
Keith
great.
and I, we know each other for a while.
Yeah,
Of course.
Go way back with it. And I'm filling in a little bit for Brooke Healy Foundation. Steve wishes he could have been here as well to present the check with it. And then I would have just been silent to this entire thing. So, but you get me instead if you don't mind as well. But yeah, your dedication has been with it all the way from the very beginning of it. Even back to the very first symposium and everything else. As a member of our medical advisory committee as well, it's very difficult to keep a secret from you and about your grant funded. But no, this grant on its surface, and I promised we would ask questions, and I do want to ask you a question because on the surface, this grant isn't just about a new type of therapy, with TP-0184. It's also a little bit about mouse models. Can you talk to us a little bit about that? What makes it special and what it's going to uncover for more than even just this compound?
Yeah, no, that's a great question. And so, like I said, the idea for this grant came about at attending one of these DIPG collaborative one, I think the one in May in Lexington. And basically, like I said, I think, I don't know if like all the families know all the intricate details of the different model systems, but basically, I think there's like this kind of like workhorse model that is used in like 80% of preclinical research to guide what should go into the clinic. So 80% of labs around the world are using the xenograft model, which is you take patients' cells. So these are from the actual patients. So like, of course, it seems like that would be the best model. I mean, because it comes from the patients. How could it not be the best model? And then you use it in mice with no immune system. So that is like 80% of all labs around the world believe that this is the right model. And of course, that is like the intuitive way to think about it. But what we've learned using a different modeling system, which is using mice that have an immune system, because unfortunately, even though the patient cells, the most models are using the patient cells, so it makes sense. But because there are different species from the mice, you have to use mice with no immune system. And what we've learned over the years is that the immune system is a really important biological component of DIPG, DMG. It shapes how the tumor cells evolve and integrate into the brainstem and invade to other parts. And I think, unfortunately, even though you're using like the patient cells with this kind of like the regular common model, like because you have to use mice with no immune system, it's you're not able to recreate the tumor microenvironment as it is in the patient. And so at least this has been our philosophy, like I said, from the beginning, from the first 2011 DIPG collaborative meeting in Cincinnati that I presented this model. And I think people still think of it as like an outlier model that, you know, is to be taken with a grain of salt. And I think that's fine. I don't want people to accept any model without rigorous data. But well, we feel like in general, we spent like, again, we've been testing stuff since 2011. So it's like 12 years of work. And it's just harder to get things to work in this model. And we believe it's because of the immune system. It is because these DIPG tumor cells, they interact with all the different stromal cells in the brain. There's like at least 10 different cell types in the brain, whether it's astrocytes, microglia, endothelial cells, different types of myeloid cells that interact, and they all secrete these molecules and talk to each other. And there's no way to shortcut that if you use mice with no immune system. So I think this proposal you're funding, it's a fundamental grant to really question like which model system is more accurate for the patients, even if it doesn't seem like it's possible that it would be this like model that we only use in mouse cells. I mean, how could it be as good as the one where you're using patient cells? You know, it is very counterintuitive. And again, I don't know the answer for sure. It's just my gut feeling for the last 12 years has been to just keep going. And I think it's important that in the field, we don't just all like follow the same current. It's important to have independent thinking, different approaches, because we don't really know which approach is really going to pan out, which modeling system is really the most predictive. And so I think with this grant, we're going to basically use TP-184 because this is a drug that's going to go into the clinic. And we're going to test different model systems because we want to see how it responds differently. And then we can compare what happens in the patients and see what is most, you know, which model is more accurate. Again, I think whatever model is the best is, you know, we'll accept it. But it's just really important to kind of ask these fundamental questions about which model system is really most predictive that will help the kids that are fighting this day in and day out. And so I think I'm grateful that the foundation really can see like a big picture question that we're asking. That's sort of like, instead of just testing a drug, we're questioning which approach. And even like, is it okay to like recreate the tumor? Do you have to recreate the tumor from the beginning? Or can you use established cells that are already like DIPG cells and then put them into the mouse and it's just as good? And I think we believe that you have to reestablish it from all the way from the beginning, from the initial cell that acquires the histone mutations and then additional ones and interacts and forms a tumor. And nobody likes to use this model because it's more heterogeneous. But DIPGs in patients is heterogeneous. There's some patients that I've taken care of that have lived 3 to 5 years and some will only live 4 months. We don't really know why that is. But I think it talks about the heterogeneity of the disease, which we think we can actually recreate with our model system. So I am grateful, like I said, and like I said, I have young people in my lab that are the future. You know, I'm approaching 50. I want to like at least have other people continue the mission until we get to the finish line. So you're not just supporting myself, but also like my young people that are going to keep coming up with new ideas to move the field forward until we get to the finish line, which is, you know, a cure for all.
Well, that your grant stood out because it was a new direction of thought, but not something that is bright and shiny. It was something that's been patterned over the years. It's been one of those hand-wringing moments that we've seen in every single symposium where we always look at it and say, is it the modeling? Is this the reason why we're getting the wrong conclusions of it? And I think that, you know, that's a healthy discussion to have. I think you also said it best in saying that you didn't get lucky with other grants, but I think luck isn't the way we're going to cure cancer. It's about a steady strategy. It's about doing this hard work up at the beginning of it. It's not chasing just what is bright and shiny, and it's sticking with it. And if anything, Dr. Becher, you're a testament to that. And I think you bring certainly that wisdom also to the Medical Advisory Committee. And we're thankful for your grant. We're thankful for your advice. And not necessarily on your own grant. You didn't get the vote on this one. But we appreciate all the work you're doing as well.
Well, thank you guys for also being there from the beginning and keep going and doing all the fundraising. I know that there's even in the fundraising world, I'm sure it's like not always easy, but you guys are always so good at it and persistent and always very organized. So kudos to you guys for doing that also important hard work of fundraising.
Now we gotta go raise another 100,000.
It's never ending, right? I mean, I think you just have to keep going, and you know, like as I've gotten older, I just focusing on the process, asking good questions, and like I said, you can't do this if you're aiming for success. You just have to ask good science, incremental progress to understand these tumors, to do the future trials better, to so hopefully that one day we get where we need to go.